The broadcast is now starting. All attendees are in listen-only mode.
Hi, everyone.
Hello, everyone, and welcome to the Serverless Observability webinar. This time around, I have featured our own guest, Ran from Epsagon.
Thank you very much for having me, Aitor. I now see that the lambda I just drew is not that perfect as I thought, but yeah, let's stick with that.
Well, you're actually a good designer. I would have drawn something else. I could probably look like a dinosaur or something. So thanks everyone for joining. If you don't know yet, if you just clicked on the wrong link, you are actually on AWS Serverless webinar about observability. My name is Heitor Lessa, and I'm a specialist solutions architect for AWS, covering serverless and any developer technologies. Call about buzzwords, microservices, anything you like.
Yeah, and myself, Ran Ribbenzaft, I'm the co-founder and CTO at Epsagon. I really love serverless, love cloud architectures, fascinated about it.
Awesome. Okay, so let's kick off then. So to get everyone on the same level, just in case you haven't been to previous webinars, the first thing and foremost is to quickly understand where serverless fits before we just dive into only about monitoring, observability, etc., etc. Think about serverless as a technology spectrum. On the far left-hand side, you will see on-premises, virtual machines, everything that you have to be responsible for. The whole infrastructure, setting up cables, physical access, and pretty much everything else that may not be part of your business or your core business value. On the right-hand side, the more you move, the closer you get to the core business and you spend more time with it. So in that case, we're going to be talking a lot about AWS Lambda functions as a managed service for functions as a code or functions as a service, and many other services that combined make up the AWS serverless platform. When we start talking about observability, there's a great book by Cindy that talk about the three pillars in more details. She also shares a lot of what I actually agree with her into observability and the monitoring piece. Observability might be a new term for some of you, but in essence is monitoring in a much better and more detailed scale with now new tools. So from an observability point of view, there are three pillars that you should know: event logs, metrics, and tracing. Each of those combined, they give you more visibility into how your system behaves, and you are able to ask questions as your system operates, as opposed to the old style of monitoring. You were monitoring for a particular failure, you know it could happen. This time around, with distributed systems, things may not be easy and necessarily well defined in how they're going to fail. They could fail in so many different shapes and forms. When you think about event logs or you think about log aggregation analytics, all of those time series data or those data that you don't want to necessarily store for only a short amount of time because you may need that later, but you don't get visibility straight away from what exactly is happening. So you may want to aggregate all of these logs, all of this time series data, and later do some analytics on top of it. Metrics is a common friend from monitoring space and alerting as well. So I will skip that for the moment. On the tracing side of things, as Ron likes to call, is the story of the request. You want to know exactly how the request was initiated from the customer and it traversed through multiple systems in your architecture. And that helps you greatly to quickly visualize what could be possibly going wrong. And more importantly, where do you actually start by trying to investigate a problem, as opposed to going straight to the logs and probably getting lost into a sea of data.
I think that the whole observability concept is about allowing you to focus on the business metrics rather than get swamped with logs and metrics and tracing all over, but to be focused on the KPIs that matters to me as a business, as my application is my front of the business, and I need to make sure everything is working properly.
Absolutely. Let's get into more details now. How does that map to AWS services, and how do you get that visibility to think about business KPIs and things like that? How does that map from a technology standpoint? From AWS services, from event logs and all this analytics and aggregation, we have a service called the AWS CloudWatch Logs. It's a managed offering where you ingest logs and at the same time search and get some visibility out of it. When you look at CloudWatch Logs Insights, you're able to query the data. Could be JSON, could be in other formats, and you can quickly draw a particular metric or visualization to quickly understand if there's any particular pattern In here, you are more interested in seeing if there's patterns into a particular aspect of the request, but you go there already knowing what you're looking for, as opposed to going trying to find a needle in a haystack. From a metrics perspective, there's definitely lots of dashboards you've seen out there, but going back to what Ron just mentioned is you can have application metrics that the cloud provider, in this case AWS, provides you, but what's most important in your business is understanding the metrics that matters to your business, the KPIs. You can use CloudWatch custom metrics to generate those for you. If you haven't watched this yet, at reInvent last year, BBC gave a talk. If you search for Dev 302 on YouTube, or that particular string you see at the bottom, you will see a much more detailed talk from BBC explaining how they created all their KPIs via custom metrics, via logs, and many others, and how they create a dashboard that can help them understand how long does it take the process end to end, where the bottlenecks are, and how they define their SLAs from a metrics perspective. If you look at the dashboard, if you can zoom in for some reason, you will be able to see some annotations in that graph. And that's very important for you to know when you have anomalies or when you actually should care about certain aspects of your metrics. I also talked about getting the metrics out of the logs from the BBC talk. And the way you do this is by using a feature from CloudWatch logs called CloudWatch Metric Filter. Essentially, it's a regex, nothing else. You create a regex that you can find patterns inside your logs, and from there you can create metrics. That's perfect when you're trying to combine, aggregate certain metrics. But if you're looking for percentiles or P99, P50, and so forth, you actually want to use custom metrics, although you should actually see it right there. From the logs as well, sometimes you already have a system in place. It's not necessary to say that you should have a system to do analytics outside, but let's say you already have the common ELK stack, Kibana, Elasticsearch, and so forth. You have Grafana, Graphite, you have all these other systems to visualize that data. What you could also do, you can stream the logs from CloudWatch and go to anywhere else. So in this case, there's a feature called subscription, where you can attach a Lambda to it or stream straight to Amazon Elasticsearch service. And from there, you can stream logs to pretty much anywhere. Common places would be Splunk or Logly or many other platforms you can see from log aggregation and analytics.
This applies also to alarms, where you can ship alarms to an SNS and then trigger a Lambda, and you can ship it to your Slack, PagerDuty, or whatever solution fits for you for alarms. But in this case, it's logs, but it also applies for alarms as well.
Actually, that's a good one. I forgot. There's an if you're interested in alarms and Slack integration, there's one that's my personal favorite open source tool. I think now it might be commercial in some aspects. It's called Marbot. I could put the message on the chat later, but Marbot.io, it's a bot that gets the alarms from CloudWatch and presents in a nicer way in your Slack, so you'll be able to reply, acknowledge the concepts or anything else you need, or even escalate.
Yeah.
On the tracing side of things, we have AWS X-Ray, which provides you the distributed tracing capabilities and the service graphs. Let's have a quick look at this. From a service graph, when you have those traces, you're able to see how systems talk from point A to point B to C and so forth, what are their dependencies, and whether there's some visible issues within that particular trace and that story of their request, be the throttling, be the errors, or more importantly, what's the average transactions, and also what's the latency distribution across those systems. But this is just visualization. You actually want to know more details, which it goes back now to Ron's point about the story of the request. How do I see every transaction that happens in there, the systems it touched, and how long did it take? Was there anything else in place? If you look closely on the graph, in the middle, there's going to be a red icon over there. And that means that to talk to Dynamo, that particular table, there was an issue. We received a HTTP 400, and it meant that that particular DynamoDB table didn't have enough provision capacity. So in that way, you can do two things. You can just change to on-demand table, so you get rid of that problem, or you actually go and investigate if that was an anomaly or if that was, in fact, you're getting more demand to your business now.
Yeah, I think that this view also provides us a way to detect bottlenecks. So in our example, we'll see that there is a thing that takes really a long time as part of our execution. But in this kind of view, it's easily, visually, you can detect what's taking the most part, where should I improve my performance or my business according to it.
Exactly. But all of these tools that I mentioned to you, all of these services, they only get you so far as well. What you actually want to get out of it, most importantly, is to understand how your customers are interacting with your systems and how well do you understand your system in case something goes wrong. There's actually that old saying where there's actually O'Reilly books covered with people who use Photoshop and saying the person who set this up is now gone. Nobody knows what's happening anymore. Nobody knows actually the metrics or how the system actually operates. I think it was reInvent 2 years ago, Nora Jones from Netflix was giving a concept of the chaos engineering, why that's important for them. If you haven't watched that yet, go to YouTube and look up for the reInvent keynote of 2017, and you'll find out more information about chaos engineering. But in summary, in TLDR, it's more on the point of actually testing your systems for failure, so you can understand where the fail actually happened, was introduced, and making sure those systems fail because you don't know what you don't know until those pieces fail. That's very different.
Yeah.
Okay, so now I hand over to Ron, and I can take some rest now for the next few minutes.
Great. So in this example, we wanted to show you something in practice. For that practice, we've created the Serverless Shop. So it's probably not the first shop built on serverless, but this one is a simple e-commerce example with lots of lots of Amazon nice products like Fire TV, Kindle Paperwhite, Echoes, and so on. Now this for us is our business. This is the shop that we want to promote and want to promote as a business. And it allows us to do two main things, or allows our customers to do two main things. The first one is to browse for items, so they can look for specific items and query information about them and so on. The other one is to purchase product, which obviously for us it's the most important business because we want to sell as much as possible. Now this store is being built 100% on serverless resources, and for you it's available for now. You can get into the https store.epsagon.io. It's open for everyone, but just make sure it's not a real store. You can't actually buy anything, but you can play with it and explore it. Now before we'll get into the store, I want to cover the architecture behind it. And when I'm saying 100% serverless, it's the serverless ecosystem, not only Lambda function, but resources such as DynamoDB, SNS, SES, all these kind of resources that allows me to focus on my business rather than setting up constant infrastructure and taking measures to know that I'm in the right scale and so on. So we'll cover it from the left-hand side to the right-hand side, starting from the upper part, which is the simple one, starting with CloudFormation and S3 bucket. This allows us to serve static files. For us, it's the website. So when you browse into store.epsagon.com, it hits the AWS CloudFront, then gets the file from S3, and you get the response. Now your browser is creating all these requests to the API on the bottom part, starting with AWS API Gateway. So this is handling for us all the HTTP requests, parsing them and getting them to the right place. And we've got two places, as we said, we've got two main business. One is to list all the items on the upper part of it. This one is pretty basic. It includes a Lambda function, which gets the request, and it gets all the latest items from the DynamoDB. And then in order to be a cool website, I've also added a feature to this business that it will get latest pictures from Google Images. So instead of having the same old boring pictures, almost every time you'll refresh or every day that you'll get into, you'll find out the most interesting picture for that product that was published around the web. So that's really great. The second business flow is actually to buy an item. And here it starts with a Lambda function that's handling the payment. So for the payment, it calls Stripe API for creating the payment. And then it calls the SNS for actually fulfilling the order. So this SNS moves the message to a different Lambda, which updates the stocks. First, it verifies that there is a stock left. It updates it accordingly. And it also notifies the user that okay, user, customer, you've got your purchase handled. You'll be able to expect shipping by some time. Now, before we dive into the specific business flow, I want to do a quick tour for the website or the store. So as you can see, it's available here. And by the way, this Win a Cool shirt, it's like participating in a survey that we're doing. It's pretty cool. We want to gather some results of the survey status for AWS Lambda users, and you can win a cool shirt in the summits that we will be there. But here you can see the items, all the items that currently the store is providing, mostly around Amazon items. We can get into each and every specific items and to get some more detailed information for each one of them. And we can also buy, but we'll buy in a moment. If we'll get into our presentation now, so the two main business flows are first to get the catalog from the API. In this one, it's getting the items from the DynamoDB and then queries the Google Images API that we'll soon see why it's having some issues upon our architecture or our business. And the second one is a more complex one, and this is one that we take into practice the distributed architecture or the asynchronous chain of events, where once a user is buying something, he wants to get an immediate response about, okay, this is I've made this purchase, I want to get notified that it's working, but I also want to make sure for us as the business that the order is being fulfilled as soon as possible. So having a KPI of how long it takes or how long the user waits, it's really hard in such distributed systems because it does not involve only a single resource. It involves many asynchronous resources that talking to each other in an asynchronous manner. Before we'll jump into the specific business flows and KPIs that we will investigate in this kind of business, I want to make a simple purchase. So let's add to my cart a Fire Stick TV. I actually really love it. I've got one in my home and I'll check it out. In this example, I'll use my own personal email to get the details, and I've got already pre-filled information for it. And we also use the Stripe widget, which is, it's just as another managed resource for me that allows me to put in a widget and it takes care for everything for me for card handling, purchase handling, and so on. For this example, I'm going to use a dummy credit card, obviously. And I'll be able to complete the order and see that I've got a thank you message. The email has been sent for me. We'll actually be able to see that the email has arrived for me now that I bought a Fire Stick TV. So it's really great. I mean, out of the box, I've created a business for myself. Actually, it took me behind the scene, if you would like to know, it took me like 2 or 3 days for making it. And I mean, I don't think anyone has ever created a business in such a short term. Now let's talk about what's important. We gathered here to talk about observability. And for me, observability is monitoring the main business flows and the KPIs and making sure my business can grow. So the first scenario that I would love to discuss, it's about the catalog, our first business of users getting into the website, and we want to make sure how long it takes for them to cover this discover this catalog, because if it's taking too long, I mean, it happens for almost any one of us. You're browsing for something, it takes too long, and then you ditch it and you never come back. We're losing business because of this thing. The other one that we will cover is about the payment. So once I already bought an item, I want, as a rest assured customer, to know that everything is being handled for me, to get the confirmation and understand when the item will be shipped to me. So for us as a business, we want to know how long it takes once the user clicked the checkout up to the point he got the email confirmation for it. So let's go shopping and let's start exploring what can happen. So we saw that in our catalog website, we've got currently 5 items only. And it's taking some amount of time to load, but it can take longer if our items list will grow. So for that, I created an endpoint that will allow me to increase the items from 5 all the way to, let's say, 17 items in my stock. So we now get confirmed that there is 17 items in my DynamoDB. And if I hit the refresh, so I'm seeing that the loading taking pretty lot of time. And it took actually pretty decent amount of time to explore now, it can happen to the certain threshold all the way that timeout will happen to my system. Now I want to talk a bit about timeouts and this limit that we need to be aware of. Now when we define a Lambda function, if we'll jump to the Lambda function that defined in our case, we can see that we got the get items Lambda function that we talked about, that it allows me to explore all these items. Now if we'll see, for example, we can see that we define a 6 seconds timeout for it. But honestly, 6 seconds is pretty long, so let's maybe try to make it even shorter, because I don't want, sorry, I'm playing with the memory. So I want it even to be faster, so let's define even 2 seconds, because 2 seconds is the amount of time that I want people to wait for. Now if I'll hit again the refresh button, so we might end up in a different scenario. In this scenario, I'm gonna see the loading roller all over without something changes. Now I'm a developer, so I know when something bad happens like it, I'll open the toolbar and I'll see that I got like an error message. And this is actually where timeout happened. It means that the Lambda ended with not a correct status. And let me show you how it looks like behind the scenes. In general, when something bad happens, or if we just want to monitor a single Lambda, there is a great pane for the AWS console that you can jump into the monitoring tab. You can filter by any time frame that you want, and we can see all the parameters that we want to monitor, the basic ones, at least the performance-wise. How many invocations and traffic do we get to there? What is the duration of each and every request in that period of time? And also to see the errors and the health of our systems. There are some more over here that we're not going to cover. But let's see how a timeout looks like, because timeout is a new kind of issue. I mean, it's something that usually on containers or EC2 instances, we're never running out of time. It can run as long as it needs. But if we'll get into it, and hopefully you haven't hit so many refreshes, so I'll be able to find the timeout in this case. Let's see if we're getting one. Yeah, so we do get a lot of timeouts, and thank you very much for refreshing. I see much more than we did. So we've got out in the end of the report line a task timeout. Now, just so you'll be aware how to read this kind of logs, so each and every invocation starts with a start indicator, ends with an end indicator, and afterwards it publishes a report line, which is good for performance metrics. And between the start to end, there will be any std out printing that you've done in your code. In this example, there is none because I'm a lazy developer. And for the report line, you'll be able to find some interesting metrics for the performance of your Lambda, including how much memory it used, what is the max memory size, and how long it took. Now, for this specific case where the Lambda timed out, there is even another line right after the report where you can see a task timed out after 2 seconds. Now, if you're not having something in place, you'll never find out this kind of log. You can use the regex, you can use something, but you'll need to set it up for you. In this kind of example, the thing that you would like to see, or first to get notified when something bad happens, because this means this timeout, and see, I'm still as a stupid customer that just logged in, I'm still waiting for something to happen and nothing happens. At this point, I'm frustrated why I can't buy my, Fire TV Cube, because I'm so interested into it. In this kind of example, behind the scene, as a business, I would like to know when it happens, or even when it closes to happen, because I want something to cover me. So let's see the way it looks at Epsagon. When fully initialized with Epsagon, you'll be able to see all of your functions, including all AWS accounts and regions. In this time, we'll focus specifically on the 4 catalog functions. So we're seeing already the catalog shop get items function. And we want to jump into it and see a breakdown, including timeouts and other issues that we had. And we can actually see below all the performance information, we can actually see all of the invocations. So currently, almost every invocation is a timeout. I think all of them, since it just can't explore too much images in the Google API. And we can easily filter, show me all timeouts, all success, show me how long it took, show me the involved resources and so on to understand what happened. So if we'll get into a specific transaction in here, because we want to understand what happened. So we got into the log. nothing was visible for us in the log to understand why timeout occurred in our function. And we talked about the story of the transaction. In this case, we're actually seeing the story of the transaction. We can understand what was the chain of events that led to it. So actually, I can see that API gateway, the /items trigger the get items. And I can see that there were one operation against the DynamoDB that took 41 milliseconds. I can also explore like what was the parameters, what was the response, including each and every item that I got from it, which is really nice. Exploring it visually wise, it's much more simpler. But then I can see that the part of the Google API took almost 2 seconds. So this is the one that got us the timeout. And we're seeing that there are 8 operations against this API. So for every item that we fetch, currently we managed to fetch only 8 out of the 17 items in the DynamoDB. We'll be able to see this operation now. We're seeing that it's taking lots amount of time, and obviously a store doesn't end up with 17 items, it will end up with thousands of items, and it just can't grow in this way. And this is a point where our business fails, and we need to make sure that we know about it, and once it happens, to be able to explore where it happened, where is the bottleneck, what taking so long in my business to take. In this example, I think that the answer is obvious. This is the Google API. I think the solution, there are lots of solutions that we can implement, but in this example, first, we might want to cache our results. So not for every request we'll query the Google API, because it's taking long. I mean, every request takes roughly between 100 milliseconds to 250 milliseconds, and it's a long amount of time. I mean, users usually don't want to wait more than a second for a page to load.
What I love about seeing the trace and visualizing that problem is, at first, it's very likely for developers to just go straight to the backend and try to solve the problem there. But sometimes, especially in the first problem I'm showing to you, you could actually solve that at the front end side of things in a much nicer way, including that spinners. If you actually go back to the store, you will see that the spinner is still actually loading. One good lesson I learned by doing another demo as well was to actually set a timeout to the promises in JavaScript and actually catch that and not leave the spinner leave there for so long. You would definitely want to give a sort of a feedback. Even if something went wrong, no matter how good your metrics are, how good your code is, if you don't provide feedback to the customers, yes, they were not going to come back.
You can always end up with like a funny, oops, something went wrong message, so the customer will be more, fun place to be and not frustrated. But yeah, definitely you need to handle these kind of errors because they can happen. Now, if we'll jump back, we'll be able to understand that we need to fix it. Also, by the way, if you're curious to which user it happened or at what region, is it specific to anything else? So we can see the exact request. We can see that it came from Netherlands, I think, NL. So thank you for trying to get into the website. I'll actually make the website work again by setting the items to 3. So we'll be able to load it up. And we understand that business metrics are important. We need to make sure that things working behind the scenes correctly for our customers and not only for, a better technology or a better thing.
Okay. Yeah, for me, it makes total sense. So we have 2 scenarios, right? So you want to go straight to the second scenario, or you want to dive into...
No, so I'll go now to the second scenario.
Okay.
Now, the second scenario, let me just refresh the page so we'll be able to explore the shop again. And now I got 3 items, so it loaded really fast. I'll make a purchase. I'll make another Fire Stick TV purchase. Adding to cart, checkout. I'll fill it out again.
And by the way, when Run is actually using the card number 42424242, this is actually the recommended fake card when you're trying to use Stripe elements. What you're seeing on the front end side of things is called Stripe elements if you're curious about it. So you use that fake card to actually simulate the transaction. Please do not add your real credit card in there. We don't want to enrich Run based on that fake website.
Yeah, so I made one purchase. I'll make another purchase for me as well. Now I'm the kind of customer that like to purchase more and more items as soon as I find it useful. So I'll buy another Fire Stick TV. I'll use again the Stripe API demo card. for it. Now, in these two examples, I saw that the order was confirmed. I got a confirmation, but honestly, I haven't got for the second one a new confirmation. So this is the first one that I've made. Sorry, this was the first one that I've made, but I haven't got for the second one something that tells me, okay, your purchase has been made. Now, I'm a frustrated customer. I haven't got a purchase or order fulfillment that I know. I'm looking at my Stripe or my credit card account, and I'm seeing that I was charged twice, but only got one item. Now, this is probably the worst thing that can happen to a business when customer is turning to be frustrated, money-wise. Not that the page was not loading, but he's ordering something, he paid for it, he wants it. It will cost you in support, it will cost you in some headaches within the company, and this is not a good practice for a business. Now, we know that something bad happened. It will tell us, hey guys, I've made an order, it's not working, please let me know what happened and refund me. And now your developers need to get, roll their sleeves and get into the problem and understand what happened. So if we'll get into Epsagon, we will want to monitor what happened to this kind of problem. Luckily for us in Epsagon, it offers a trace search where you can filter any parameter that you're storing or any parameter that Epsagon already collected for you. So in this example, I'll filter the previous confirmation that I got, and I'll be able to see the exact runtime, the exact order ID that happened in this same Lambda. And actually, instead of just having a short story out of it, I'll be able to get a full story out of it in here. So it started with a buy item. Hopefully you all can see that. I'll try to review it one by one. It started with the buy item API gateway request. I can also see the information there. It went all the way to the dev payment. So the payment is the first Lambda function that handles the payment for the user. Then it used Stripe. So Stripe was used here for making the payment. We can actually see all the detailed information, like the response body that let us know that we charged the user successfully at which endpoints and everything that happened. Now, as we said, we want the customer to get notified immediately. So the Lambda is publishing a message to an SNS to handle this order, but it replies immediately to the customer, your order has been confirmed. Next, we're going through the SNS. Now we're talking about an asynchronous transaction. Trying to look at asynchronous transactions where they got more than one step, sometimes it can be 10 steps, and trying to correlate between them is very hard. But when you've got this kind of visual story that lets you know from all points to what happened, it's really easy. So if we'll get into the Lambda that is taking the order fulfillment and taking care to update the DynamoDB with the new stock, we'll be able to see that an error happened over here. And we want to troubleshoot this kind of error actually to understand why it didn't work so well. So we got that in this example, the email was not verified. I mean, in our example, we placed an email that is not correct. We'll soon show some more examples to it. But it's really nice to see that, thank you, DDD, that something bad happened. We know that we charge you for good or for not. But something bad happened according to the SCS, and this is the response that we got. We can see the actual body that we tried to send him, the subject, everything that happened against this resource. We can jump into another example of a bad transaction that failed in the stock. Like in our example, the exact example that are already captured, we failed when we checked the stock. So it can happen a lot that two people compete for the last part of stock and we haven't updated the front end yet, some sort of, a race condition. So we see the same path with the API gateway, Lambda function, Stripe, SNS, Lambda, but now we see a different problem. This problem now happens at the DynamoDB, and it can let us know if we'll zoom into here, that we got a conditional check failed exception when we call the update item. And specifically in our code, what I did in order to use the best practices is to reduce the stock, but also to have a mechanism of fail-safe that if the stock is 0, because DynamoDB can store for me the amount of stock that there is left, if it's 0, I don't want to get into a minus amount of stock left, because then I'll need to make something, I know, out of the box to get this new item shipped to the customer. So I'm getting the message, but I'm not handling it very correctly. In this example, it's just this Lambda fails, the second Lambda, but I've already charged the customer. I haven't sent him any email about a confirmation that it's okay or not. So it's a really bad practice to use that, but at least we got to know what happened in the store. We can recharge back the customer by looking at the Stripe request and understand what was the ID of the customer and detect that issue. And I think in order to really improve that to be working correctly, the right way would be either ship an email to the customer that will tell him, hey, we find out that there is a problem, we're sorry for the inconvenience, we'll make sure to refund you. Otherwise, we can do this automatically and just send an email that we're sorry, the item is not available now. If you still want to purchase it, please send us an email. So this is actually looking at the business behind our application. And for everything here, we can answer the questions for how many errors there are, how long it takes from one end, from the customer requesting to buy an item, all the way to it finish. In this example, it finished with an error, but even if it would finish with a good handled scenario, we would want to know how long it takes. So it's really great for us to detect these kind of things. Last but not least, you want sometimes to see things visually rather than looking at each and every transaction. So I know this might look a bit complex because we got a pretty complex scenario. We've got a few Lambda functions, we've got a DynamoDB table, we've got some APIs out there. So in this example, we'll be able to see all the APIs that we're using, including the API gateway, the Lambda functions, and for each and every one of them, we'll be able to see the performance metrics that they got. So in this example, we can find out that get items, sorry, it popped out. We can find out how many events there are per second. In our example, it's pretty low because only us using the website, but it can grow to a much larger number. How long it takes usually? So it takes 1 second in the average duration for customers to browse in. It's not a good experience. It's something that we need to improve. And using the transactions and all the information Epsagon provides, we can easily do that. And also to understand that there is a high amount of errors in our application that we need to improve. I think that this one covers all the aspects for the shopping. We can cover quickly the scenarios that we've just done. So first one is when a business grows, and we want to make sure that as the business grows, the customer experience becomes the same. And we saw that in this example, it's not as we expect. We've got a bottlenecks in some of our resources. Even external APIs can be part of our bottlenecks. And the second one is that there is out of stock, or let's call it a race condition in our stock or our service that we provide. In this example, we ran out of products and the purchase looked successful for the customer, although he won't get any item, he won't get anything, and we wouldn't even get notified that something bad happened for him.
Before you go to summary run, can you actually go back to the dashboard? I just want to call out a few things because I think it kind of goes to some of the questions people asked, and more importantly, to help with kind of good practices in general. If you go to the list of traced executions, I'm particularly interested in those retries that happened as well.
Correct.
So if you look, I think it was from, I'm not sure if it was a gap item or the order fulfillment.
The order fulfillment one can get some timeouts.
Yeah, one of the interesting pieces.
Sorry, it gets exceptions.
Yeah, if you go on that one, you're going to find some duplicates in transactions, the request IDs. Yeah, so this is if you haven't read yet, there's a white paper called Serverless Lens. Obviously, this webinar will be too short of a time to go through every best practice you need to take into account, show you AWS X-Ray and many other services alongside these things. But it's important for you to know on the left-hand side that the retries can happen because they are so idempotency is important. But one really quick trick that you can use is looking at AWS the request ID that's generated by the root of that service. So in that case would be SNS, and you will be able to do a quick condition like a if, for instance. And if that request ID is the same, then actually there's no need for actually doing the same operation over and over again. And that helps you in so many ways, from the backend side of things, from the database, items, duplications, and things like this.
Yeah. Also, we can see it visually. In this example, we can saw that the Lambda was being triggered multiple times, the order fulfillment. So we can see each and every retry attempt and understand if there is any inconsistencies. For example, if the one that handling the payment had been triggered more than one time, we would charge the customer more than one for something, and it's also a bad habit, and we need to understand when it happens. I mean, it can happen to anyone, but we just need to make sure that we know that it happens.
Yeah, and one important piece as well, it's also kind of in the paper, when you talk about visualizing tracings or visualizing data, whether that be X-Ray, Epsagon, Tundra, or many other products in general, it's one of the important pieces. If you notice, when Run purchased the order, there was a request ID for that particular order. And he used that order in order to find out within the haystack what transaction actually belonged to that particular user.
Yeah.
If you were using AWS X-Ray, for instance, you could use also custom segments in exactly the same way that Epsagon was doing. So you could group by all those traces for that particular transaction, or you can find, for instance, a particular user attribute or something else that your front end can send as part of metadata. So having a correlation ID that helps you find those transactions, or be that in logs or metrics or tracing, is actually crucial to you.
Yeah. Also, I constantly hear some questions about why should I set my timeout to a low number? I mean, I'll set it to the maximum allowed timeout, 15 minutes, and it will work. Timeout wouldn't occur. So first, I would say that it's not a best practice. I mean, you need to be aware of how long the code takes. And if, for example, I would get into the story, it would take more than, few seconds to load, and instead of it will take 60 seconds, I won't wait. And I won't even get notified that something bad happened because the timeout haven't occurred. So in this case, we do want to limit our timeout to the right amount of time that we want to, and just make sure that we're handling it correctly in the front end to place the right message when something bad happens.
Yeah, and there's one last piece before you just go to the summary and give you a surprise at the end. If you go to the architecture view, we also covered that into the serverless applications lens, or serverless lens. I'll send you the link in a minute. But essentially, every arrow that you see in the architecture is a potential for failure as well. Even if you're using serverless and where AWS is managing those services for you, patching, you don't have to provision, you pay by value and all that, you still have to do all of this good, I would say, distributed computing practices, from thinking about the retries, thinking about the backup, whether that's going to be a timeout, or in serverless, in that particular case for Lambda, it is not that the timeout is the issue, but more that you have a limited execution, the duration of that environment that you're going to run into. So in container, for instance, when you're using ECS or Fargate or the services or Docker itself, you may run a particular transaction for minutes or maybe hours until you find the problem that's actually happening. In Lambda, because you have that constraint into the execution, you'll find that problem a lot sooner. But it doesn't mean that you are free of the problem. It just means that you have that problem happening more often in this case now. So good monitoring practices, no matter what tool you are using, is actually crucial. And let's go back to the summary, and then we go hand over all those questions we have to handle to.
Perfect. I'll start with, I think, my summary, and I would love to hear yours. So first, I think that we all agree here that serverless is great. It allows us to really get started with the business quickly as we want. As you saw, this example that you're browsing with took like 2 or 3 days of work, and I've got a working business that I can actually get paid from pretty quickly and pretty easily. But when we're talking about the modern architecture software that is comprised with hopefully as many managed resources for us, we're talking about much more distributed application that contains lots of resources that are talking to one another in an asynchronous methods. We need to make sure we've got the awareness or the observability to our application, or let's say the observability to our business. We need to make sure that before we hand our business to production, we know what we want to monitor and what are KPIs for a successful business. It relies to almost any kind of production application, but I think in serverless, since you're ending up with lots of resources and lots of events, and most of them are asynchronous to each other, it might be harder to implement those because it's not a single monolithic application that you can monitor from one end to another.
Absolutely. And it's also interesting that you should know that the link I sent you, you'll cover in a much greater details about what you should do before you go to production with serverless. Serverless it actually brings new challenges when you think about it, because you don't have access to the underlying infrastructure. You no longer can use those traditional tools that would bring you agents to monitor, or let's say I have a man in the middle to inspect your network traffic and things like this. You have to definitely have tracing all those pieces we covered at the beginning of the presentation in order to gain some visibility into how this application is actually going through.
Yeah, and I think, if I'll talk technological wise, what's the difference is first that you've got no access, so no agent can be introduced. Everything is ephemeral, and we've got this issue that we need to make sure our code run in the limited environment. And also for some people, cost is starting to be an issue to make sure that we know that we understand how much our business cost us. We'll be able to figure out what is our customer cost to handle this purchase, to handle this get items. So we'll be more aware of the business implications of the cost rather than just random calculations.
Yeah, it's also interesting because when you compare, it is not strictly to serverless, but more of a distributed application as a whole. And more importantly, one of the great benefits of serverless is because you're now paid for what you're using. So it's 100% of usage.
Yeah.
And in the server model, you would actually have to pay in advance, getting the infrastructure put in place before you actually even use. And it doesn't necessarily mean you're using everything up front. That also brings a different way of looking at cost from a different perspective and lens.
Yeah, I really love that you said distributed applications and not only serverless, because this, and I think the last slide that we will share today, is that we've got some challenges in distributed applications, in not only serverless or not only Lambda functions. In these kind of applications that we see, for example, the web store, we need to manage lots of resources and APIs, for example, the SES and the Google Images search and the SNS and so on. We need to make sure we know how to cover each and every one of them. Also, we want to be able to measure our performance from one end to another rather than each resource individually, because stitching them all together might make no sense if this architecture will triple itself or even more than that. Also, we need to make ourselves feel comfortable when we explore a problem using the logs. So we'll need to share some sort of a unique ID, or to be able to correlate between logs of different Lambda functions and different resources to be able to pinpoint a specific trace throughout our system. And there is also distributed errors that with the logs will allow us to understand them and fix them, but we need to know that we want to connect what happened in the chain of events and not look at each and every resource individually, because it would be much harder. It can't be applied in here as we used to do before.
Okay, so let's actually go through some of the questions. We actually got quite a lot of those. Do we want to enable the webcam just so, because there's no content actually being in place?
Yeah.
So if you haven't got your question now, please feel free to do it. I'm just going to read from the other sides. So the first question comes from Lucas. Where does ECS fit on the page for operational responsibility models? If you go back to the very second slide, Ron, you're going to be seeing, if you go back in there, yes, that one. So when you look from like spectrum perspective, you're going to see containers in the middle to the very close to the far right of things.
Yeah.
You're not necessarily seeing ECS as in not Fargate, but you see Fargate in there. So that kind of helps you, that even though containers will definitely help you massively when you're trying to lift and shift, and when you're trying to get more operational readiness, and also got all those tools that you have access to, the portability that Docker brings into you as well. But it also means you still have to manage all of the servers in place to actually scale, even before Fargate, by the way. But you also have to manage the whole Docker, the imaging, and the whole security aspects of scanning the images and making sure everything else goes into place. You don't want to bring in a Docker image of 1 gigabyte. You actually want to trim that down. So you are still actually working more operationally with the technology before you get any value directly delivered to your customers. When you go to the far right-hand side, you when you go to DynamoDB, for instance, as a managed NoSQL database, you're not even trying to select how many writes and reads do I possibly need.
Yeah.
You actually just start using right away. When you look at API Gateway, for instance, the API run was using it, you simply set up an API, connect to that Lambda function or to any other service, and you simply start using it. If you're not sending those requests, you're not paying for it.
Yeah.
So that's actually what we mean by that technology spectrum from left to right.
Yeah, I think that serverless, trying to sum it up, serverless, it's not binary. It's not 0 or 1. It's a spectrum, and you've got resources that are more serverless and resources that are less serverless. And hopefully what each and every business is trying to do is to go to the maximum right-hand side of this spectrum.
Right. Lucas, I will answer one more question to you because I know there's a lot of others, so I just don't want to pick up any favorite. But you can see our Twitter as well, so you can actually pick them up. Your second question is about we are not calling Lambda from Lambda, which seems to be critical in a traditional microservice system. Would you not recommend doing this because of latency? So initially, you don't want to have Lambda calling Lambda that calls another Lambda and so forth. Remember the discussion we had when we showed the architecture. Every arrow you have, it could be a possibility of failure. So if one Lambda calls the other in a synchronous manner, that calls another one. If one of those Lambdas actually fail, again, you have complications in there. Mm-hmm. And more importantly, the customer is actually waiting that call to another call to another call and so forth. If you had a particular very strict latency that you couldn't use an API or any other form of contract between those microservices, yes, I mean, you could definitely have one Lambda call another one. But as soon as you have one Lambda, and another, you ended up actually in a much worse situation than if you were compared to a monolith or something else, for instance.
Yeah, I call it the serverless spaghetti.
If you go to that link I sent on the chat, the bit.ly serverless _lens, we actually cover pretty much all of that. We cover the microservices pattern, what we think is good, what we think is maybe not so good for now, what could definitely be improved. We talk about the Saga pattern for making transactions and rollbacks and everything else you should know. So check this out.
Yeah, if you're concerned also regarding the performance of what it best to choose SQS, SNS, Kinesis, or even directly invoke a Lambda, I remember that I did a year ago a benchmark to all of these services to understand how long it takes to send a message and how long it takes from A to B, the amount of time it takes. So it's available on the Epsagon blog for you.
Okay. The other question is, what are KPIs? So KPIs are key performance indicators. In case I got the acronym wrong, I usually have a bad memory on that one. Essentially, when you go back to that particular store, say for instance, you want to know how many customers are seeing your products. How long does it take to a customer seeing all your products, or at least the first pent of it, for instance? There's a tool for this called Google Lighthouse. It's actually available on the Chrome itself and also as a CLI that you can use. But the KPIs for us in that scenario is, because serverless allows you to focus straight into what your business needs to deliver, and not so much on the provisioning and infrastructure side of things, you now have way much more time to invest into understanding what are the metrics that your business actually care the most. Because you like Ron was saying, 2-3 days to develop this basic shop. He could also spend about 1 week just creating all the possible metrics and dashboards that the business would care. How many customers were able to purchase items? How long did it take for them to purchase the item? How many customers failed to pay? Maybe there's an issue in the payment system. Maybe it's their credit card. You don't know. All of these metrics are not application metrics. In fact, if you open up the link I sent you and go to page 28, you will see a list of every possible metric you should have before you go to production, not only with serverless, but any other distributed systems in general.
Mm-hmm.
Can I get a link to the code sample applications?
Yeah, actually, I forgot to share it. So it's available under the Epsagon repo, serverless-catalog.shop. Hater will soon share the link to it. Both the backend and the front end are available here. Hater and I just discussed about it, whether you'll roll your sleeves and make this backend work even better, or even the front end to show the appropriate messages. So feel free to contribute and open PRs to that in order to improve our not so great business shop.
And by the way, remember that this is just a fake shop. particularly built to show you some of the problems you commonly would see
Yeah.
it. It's not built with best practices or anything like this. In fact, you can solve pretty much most of the problems, if not all of them, just by doing some of the work on the front end. There's one question that I will answer with more details on that one. So here's the link I sent you on the chat. Everyone should be able to have it. Second question, yes, will the code be available? You now have it. How can we handle Lambda timeouts more effectively? So again, on that page I sent on the serverless lens, we cover a bunch of things on how you can better cover that particular timeout. So when in asynchronous request, for instance, you can have DL queues. If that message failed to cover X amount of times, you don't lose that transaction, but you send over to another place where you can redrive those messages back to the queue, or from DL queue to a normal queue or something else. Or more importantly, when you're trying to calculate timeouts, you don't want to calculate that by hand. So you can use a service called AWS Step Functions. And there's a great project by one of ours, evangelist called Alex Casalboni, who basically created a step functions that would invoke your function multiple times with a particular payload, a given amount of times. And you should be able to know how much memory is actually needed, how fast it actually is, and what was the cheapest option. When you think about how fast it is, you can already cover from there a particular timeout. You're always going to have an additional 1 or 2 seconds, maybe 3 seconds to what your transaction actually takes. So you can cover things like networking being flaky or other aspects of retrying or things like this.
Yeah. The first thing you need to be aware of timeouts is to know that you've got these timeouts and then understand what's the best practice to handle them, either by changing the architecture, changing the anything in your code that will not affect for you again.
Exactly. And more importantly, every time you see an error, think of it, there could be a timeout, there could be a retry. Who retries? The client, the caller, or the person or the backend who's actually making that call? How many times does he retry? Does he have a circuit breaker in between? Does he stop at some point? Does he send a message to a DLQ? All of those aspects are covered in the serverless application lens. All right, next, how do you integrate Epsagon into a serverless app?
Okay, so this is actually a great question. The easiest way to answer it is just to get into the Epsagon product. There is a built-in wizard, but in general, try to sum it up. The first one is to deploy CloudFormation that will allow us to get all of your functions and read the logs in order to be able to show you all these kind of metrics. The second one is to add the Epsagon library. So if I'll go back, you'll be able to see at Epsagon that we support Node, Python, Java, and Go, that you'll be able to add into your code, and traces will be generated automatically for you. Not as other products, it's automatically telling you that here you interacted with the DynamoDB and you got triggered by an API gateway, you published something to an SNS. Every event is being captured for you, so you don't need to handle all these things around the code.
Okay. The other question comes from Samir. You mentioned caching. How would you solve this? Any suggestions or any patterns, resources I can learn from? So definitely there's so many resources about this. You have, especially from a front-end perspective, you have places like Free Code Camp, you have Front-End Masters, or many others. Ping us on Twitter. Happy to share those with you. From the loading the images itself, I could give you some of the answers right now. I'm actually really willing to share, but then I would actually kind of destroy the party of fun of some people trying to solve it. But this one of the secrets and hint is you can solve and optimize this from the front end. No need to go that on the back end.
Definitely.
Ping us on Twitter. We give you a DM us, send us a direct message, and I can give you the answer. So you can do it yourself. See if you can get ahead of the competition. So the code is available. Yeah, we just shared it with you. In terms of analyzing, that's not a question, so I'm going to ship that over, and that's not a question either. Josh, you asked the question, but you answered yourself after. So.
That's a great question.
And another one coming from Roman, what about PII data? Is that a response? Because when you went to the traces, we could see some of the data coming from there. Is that a developer responsibility or is that Epsagon responsibility?
So it's both responsibility. Epsagon makes sure that data is stored securely. We, by the way, both running on AWS best practices, but it also can be defined by the developer. The developer can choose for which resources he wants to store this extra data. I mean, this extra data helps us to understand which user was it, what the item at the DynamoDB was it, what email we sent to, but you can select to opt out this information. So there won't be any sensitive data. You still get this visual story of a transaction and all the resources, but it's definitely up to your configuration.
Okay. In kind of a rule of thumb is any sensitive data you have, yes, encrypt it.
Yeah.
Or do you really need that data being shown somewhere else? Like, for instance, when you use AWS Lambda, nothing gets shown in the logs unless you choose to.
Exactly.
Unless you do a print in your logs. Otherwise, nothing's going to get there. Same with tracing, same with Epsagon, same with AWS X-Ray, Tundra, and many others. Samir, I'm going to jump this because you already asked a question and you, Lucas, as well. So I need to make sure we have other people to ask as well. Can you share the code? Yes, we did already. Josh, going to jump you there now. Can this tool be used with any account in Lambda deployment?
So what was it?
Can Epsagon be used with any AWS account in any AWS Lambda deployment?
Yes, any Lambda deployment, any code that is supported by Epsagon and multiple AWS accounts, we're already supported as many as you want. I mean, I do find out, I just asked you an hour ago, what's the best practice that you offer for users to use different environments in AWS accounts? So we do find out customers using 3 or even more AWS separated ones, one for dev, production, staging, QA, pre-prod. So yeah.
Mm-hmm. The other question, can tracing be done if Lambda isn't being used?
No, unfortunately not. Tracing is an actual live event that happened in the system, in the application. So if it was not invoked at all, there is no data to capture. So it only happens when something actually is running. It applies to almost any distributed tracing performance monitoring solution. So you need it to be invoked.
Right. So Matthew, I'm not sure about your use case because you don't have any context, but let's say you're only using API gateway that calls ECS, Fargate, or something else. Yes, you can have that on AWS X-Ray. You can actually enable tracing per product in API gateway, for instance, and you can see the request going from API gateway to, let's say in this case, Google Images or someplace else. So yeah, that is possible, but again, even if it's possible to not have it, you want to have that story tracked all over the place.
Yeah.
Is the front end based on React?
Yeah, it's actually the front end based on React and design. Thank you.
I mean, I'm not a big fan of React. I love Vue.js, so Vue.js is the best. But you know, pick and choose. You covered that question already. How Epsagon is getting that data, so you have the tracing in place. How to see the architecture view? You kind of showed that already.
Yeah, actually, it's in here. I promised you getting into Epsagon, it's a matter of 5 minutes. So if you've got this 5 minutes spare, just get into it, sign up. The wizard will walk you through how to get up and running with your application in here. Okay, so let me see what else. Where would you start a request ID checking for a retry? That's a great question. How would you start a request ID when checking for a retry since the function is stateless? I gotta stop you for one moment for that question. If you'll open the Epsagon tools, you'll see in the Epsagon built with React and designed in serverless with the Epsagon bunny logo in here. Just something that I love to show off. Sorry. No problem. So when you look at that paper again, I'm sorry to refer to that paper most of the time, but that's exactly how we write all of our lessons learned over the years with customers on the serverless lens. So when you execute a Lambda function, we create what we call execution environment. And that environment where your container runs, the code runs, we don't destroy that exactly right after the execution has finished. We keep that for some time. And basically, if the function gets executed again, in that case of a retry, you can access the global scope. So essentially, you can, anything that you have connections or anything that you can reuse, so you don't have to keep creating, let's say, a SDK connection, a client builder in Java, for instance, every single time of the transaction. You can do that at the very, on top of it. And you can use that, your global scope, your static class, for instance, static members, in order to get access to that content. And from there, you can just do it. For instance, a quick trick you can do in AWS X-Ray. If you want to know how many code starts you have and how actually, in fact, they impact your business and whether that impacts at all,
You can use the global scope and have a Boolean flag, for instance, and you can toggle that
Switch it, yeah.
exactly at the handler, and you can use that as your annotation when you're working with AWS X-Ray.
That's what we're doing, by the way.
Here we go. So found the secret. Okay, so that's another tool. And last few days I was playing with Lambda. My application is on Django, so I use Zappa.
Zappa is great. I love
Yeah,
Zappa.
can I use Django without Zappa? And I want a third party to deploy. So because Lambda, so I mean, in one way you could, because Zappa actually does it, but at the same time, remember when we discussed about lift and shift to containers first and then actually going to Lambda afterwards? There's no problem per se of trying to run Django in that scenario, but because you actually pay for the amount of transaction it takes, you are bringing a lot to a simple function that may not need it. Sometimes I've seen encounters of time with customers, especially in Java. All you need to do in Java for that particular transaction, look at the request, make a code to a database, JSON that response, and send it. You don't need the whole Spring Boot application actually to just do this. That's a bit of an overhead. It's not that you cannot do it. It's more about, should you do it?
Yeah, right. You should separate it into different requests that handles what they need. By the way, if you want to know behind the scenes, what Zappa is doing is getting the request from the API gateway and then parsing it to the right endpoint of your Django application, Django or Flask or any other application.
Awesome. The next question comes from Shakti. Could you clarify the role of the Google API in the architecture?
So what happens with the Google API in this architecture is that the pictures are being generated at the API. So we can, I'm not sure if the pictures will change now, but almost every day, I'll leave the store open so you can get into it. Almost every day, the picture will change to the picture that is most popular by Google search at the Amazon website. So I want to get like the most likable picture and most dynamic website, because people getting into the same website every day and it looks the same, it's kind of boring, and every day you'll get something new for each product. It's much more fun experience to be in.
Perfect. And by the way, if you're curious, open up Chrome developer tools as well, click on the network tab, and you see the calls being made as XR. You can filter that by that. Is Epsagon a SaaS software as a service solution? If yes, then how data is ingested? Well, can you kind of cover that with the traces?
Yeah, it's a SaaS. We get it from the traces all the way to our backend. If you'd like some more information, DM me on Twitter or in my email. I'm available there.
Awesome. Other question comes from João Lacerda. I'm Brazilian, so I can pronounce your name perfectly.
Nice.
So João, yes. So you showed we showed Epsagon. Is there anything else equivalent on AWS side? Yes. So you have AWS X-Ray, which you showed in the presentation first, explaining how you can use AWS services for doing exactly the same. So you can have AWS X-Ray, which integrates natively with Lambda, but the same process applies. You need to get a library, and then all those traces are going to be forwarded over to that service, in which you can visualize those traces and start diving into that data. Exactly the same as Epsagon was doing through their console.
Exactly.
So the concept is the same. Is there any tutorial or detailed description that shows how you built this store?
Unfortunately not. I might do it if some more people will ask for it. You can open an issue on the GitHub repo, and if so, I'll give you the hints or what I did step by step in order to build the store. But otherwise, the store is available, like both the backend and the front end, and the architecture is available on the GitHub repo. So you can start from there. And if you've got any specific question, feel free to DM me or Heitor.
Yeah, I'm actually just looking for a quick, there is I'm not sure how much has been updated so much, but maybe you want to check this out. It's not the same, but there's a workshop that I think is so many hours. It was actually a close friend of mine, a colleague of mine, who actually built this. It's amazing. It's actually how it builds an entire e-commerce. I wouldn't say commerce, more of a ticket system to see concerts and popular gigs. And it builds everything from scratch, from search to database to data model to local development, tracing, logs, everything else. And I'm sorry, everyone. I know there's so many more questions, which are like, wow, please send it over on Twitter for us. If you go to the very first slides, the first slide, you're going to have our contact details You can reach us there publicly. We're more than happy to answer to you.
Definitely.
And apologies if we couldn't get to every question. I know I just scrolled this here. There's probably 30 more. So I will have to stop you at some point. Otherwise, people will kick us out of the meeting room, right? So thank you so much for joining us.
Thank you very much, Heitor. It's been a pleasure.
Yeah, and thank you everyone for watching. This has been a great pleasure, and hopefully to see you on AWS Twitch on the 24th of April. For those who stayed at the very last minute, on the April 24th, we're gonna start having a live coding series that's gonna last for about 3 months, where I and a few featured guests will be building a whole airline from scratch of using all those tools you probably know. And this time we're gonna be using Vue.js.
I said that I wanted to be a guest, but now it's Vue.js, so never mind.
Thank you, everyone. Have a great day.
Thank you. Bye-bye, everyone.